All right, so put these steps in the mechanism of chymotrypsin catalysis in order from first to last. Note some references may not break out each of these steps individually, but all steps should be ordered. There will be 8 steps. Okay, so we go through and we're going to have to take these steps from the answer bank, put them in the order right here, right? So to be honest and frank with you, this is one of those times where it would be much more effort to go through and logic through every single thing. I would actually recommend partially memorizing and then use your logic to break things down when you don't remember some of the steps. You understand what I'm saying? So I'm kind of going to try to do that, okay? To help you sort of reason out where you could go if you had issues, okay? So, all right, so the first step should be His 57 catalyzes removal of H from the Ser 195 hydroxyl. Notice this one, next one right here is Ser 195. See that? Okay. So Ser 195, nucleophilic O, attacks carbonyl C of substrate. Well, you wouldn't have a nucleophilic O if it had a hydrogen on it, right? It wouldn't be as good of a nucleophile. So you actually can already organize these two within each other, right? Okay, is that making sense so far? Again, you do need some level of memorization to get through this. It's not gonna fully, well, you could logic it out. It's just going to take so much work that's not worth it, okay? By the time you get done with this, you could have done 5 other questions, right? Okay. So, His 57 donates H to N of Sesyl peptide bond. Tetrahedral intermediate decomposes. Okay, so the His 57 needs that donate an H to donate, right? So you know it has to have at least come after that, right? You also know that these things have to be near each other, attached, to make some sort of tetrahedral intermediate, right? So it makes sense that this is before this. You see that? Okay. The portion, the C-terminal end, of original substrate with new amino terminus diffuses away. Okay, so this is obviously after you've done some portion of this reaction, right? Specifically, you have to have detached something, right? And notice what it talks about. The C-terminal end of the original substrate with the new amino terminus diffuses away. So you probably had to have broken some sort of amino terminus, right? And notice here what you do. Donates an H to the N of the Sesyl peptide bond. Tetrahedral mediate decomposes. See that? So again, you're talking about that an N, which is an amino, right? So you're reacting on an amino end, it decomposes, drifts away, doesn't it? Okay. Okay, so water donates H to the His 57. This is where you kind of need to memorize some of this to get something going, right? This would be very difficult without it. So water donates H to His 57. It looks very similar to this, but you need this to come from the hydroxyl, or else you won't have a good nucleophilic O, right? Because that would give it a negative charge, which makes it a much better nucleophile. Okay. Notice it does not have an H anymore because you used it. Okay? So that gives you a context, right? Now, honestly, whether these actually happen in this perfect order or not, I wouldn't want to make a bet. But, because they're somewhat independent, these two steps, right? You could have one actually happen before the other in actual reality. But anyways, this obviously needs to happen after this. This sets up the rest of these, right? So water donates H to His57. Resulting OH attacks carbonyl of remaining substrate. Well, you've made an OH now, haven't you? See that? And so, resulting OH attacks carbonyl of remaining substrate. That makes sense, doesn't it? That fits there. So it's kind of like a puzzle at that point. Or you could have had this memorized, in which case it's not a puzzle at all because you know. Yeah. Anyways, His57 donates H to Ser 195O, leading to collapse of a tetrahedral intermediate. So notice we had the N here, right? We detached it. We're left with that O, aren't we? Okay? And so now we need to donate that H to that Ser 195O there. Okay? And again, that's going to collapse that tetrahedral intermediate. The portion N-terminal end of the original substrate with the new carboxylate terminus diffuses away. So these two things are linked heavily, aren't they? Okay? You have an O, which gets an H, and now it can no longer be in a peptide linkage, right? Because that requires the You don't have the carboxylate in between the amine, right? You don't have that O having an H on there when you have a peptide linkage, do you? It's only when you break the peptide linkage that you get the COOH, right? Okay. Okay. So once you figure out one of these, you figure out the other, right? Does that make sense? They have to be linked. And this one actually tells you this is going to happen right here, right? Okay. Does that help? Anybody have any further questions? No? Okay. It is vastly easier if you have at least part of that memorized, because then you have to take much less time and effort to reason things out. Okay? But yes, you can pretty much reason that one out. That actually does work. Okay. Let's see.